So this is volumetric strain. Volumetric strain, the formula for volumetric strains remains same no matter what. Even for circular, even for sphere, even for rectangle, even for any shape. This remains no, not for any shape. For a shape which is like prismatic or spherical or something like this, which is like some symmetry. And if it is not symmetry, then the volumetric strain is just final volume of the body minus initial volume of the body divided by initial volume of the body. So if any random shape is given, then this is the formula. And first of all, as there is a volumetric strain, the volumetric strain can only be occurred by normal stresses. Shear stresses has no effect on volumetric strains. So this is the rectangular block in which there is a triaxial loading. Due to triaxial loading, the change in length means Ex is equal to delta L by L is equal to this. Ey is equal to strain in y direction. The definition of strain is just like this. Change in breadth upon original breadth. Change in breadth final breadth minus initial breadth divided by initial breadth. This is the formula. Delta B by B is equal to Ey is equal to sigma y by E minus mu sigma x by E minus mu sigma z by E. And delta H by H is equal to this. So the formula for volumetric strains remain the same. This. So delta L by L plus delta V by V is equal to EV. The volumetric strain. This is the volumetric strain. As this denotes normal strain, this denotes volumetric strain is equal to tensile strain. Strain in normal strain in x direction plus normal strain in y direction, normal strain in z direction. This is the thing. Now there is one more thing. We can also find for a rectangular bar or for a for a cube how to find this volumetric strain easily and fast. There is a thing called K is equal to bulk modulus. The definition of bulk modulus is volumetric stress upon volumetric strain. So after many derivations, the formula of volumetric strain comes as sigma x plus sigma y plus sigma z by 3. So suppose this is kept in a water. In water there is this and this. So sigma x is equal to minus sigma y is equal to minus sigma z is equal to minus sigma, because it is compressive and it is equal in all the directions. So in that case it is minus sigma by 3 is equal to minus sigma. So in that case you can find volumetric strain is equal to of this cube is equal to now I am going to talk about this again. So if there is a cuboid, a rectangle placed in a water, every side faces equal pressure. Equal pressure means equal stresses. Every side is induced to equal stress. It is minus sigma. So sigma x plus sigma y plus sigma z by 3 is equal to volumetric strain is equal to minus sigma plus minus sigma plus minus sigma by 3. It comes out to be as minus sigma, and K is equal to minus sigma by volumetric strain. So volumetric strain comes out as minus sigma by K. It is valid for cuboid, rectangle, this. Now if there is a cylinder which is placed inside a water, this side will face P pressure. The whole circumference means suppose this is a bottle, then this whole circumference will go under circumferential pressure. So and its value is also, of course, minus P everywhere it's minus P. Now how to find volumetric strain for this? No worries, just like we did for pressure vessel, it is no problem. We know V is equal to pi by 4 d square L. So as we studied in class 1, delta v by v is equal to 2 delta d by d plus delta l by l. So no problem. Delta L by L is equal to, it is then you cannot use this volumetric stress upon volumetric strain is equal to K, but you can use delta L by L is equal to sigma x by E, and it is a rectangle, so sorry, it is a cylindrical. So for cylindrical, there is no there is Ey is equal to Ez, so minus mu sigma y by E minus mu sigma z by E, इन दोनों की वैल्यू बराबर होती है. चेंज इन डायमीटर बाय डायमीटर इज इक्वल टू, ये this is x axis, this is y axis, this is z axis. Y axis the dimension are delta d by d, it is sigma y by E minus mu sigma x by E minus mu sigma z by E, and delta d by d, of course because in z direction so the dimension are diameter only, sigma z by E minus mu sigma x by E minus mu sigma y by E. From here both represent delta d, so from kata pt you get sigma y is equal to sigma z. So delta v by v is equal to 2 delta, write this 2 times this plus delta l. You will find volumetric strain if the cylinder is placed inside of water, and the value of sigma x is equal to minus p, the value of sigma y is equal to minus p, the value of sigma z is equal to minus p. So of course minus minus it will become plus plus plus. This will become minus p by E, minus minus plus plus mu p by E plus mu p by E. So you can find that concept of bulk modulus is equal to volumetric stress upon volumetric strain is mainly useful for rectangular. If sigma x, sigma y, sigma z are given, then you can easily find the volumetric strain. Tensile strength, कितनी normal stress material will handle. Shear strength, कितनी shear stress the material will handle. E is equal to 2c plus 2c mu, E is equal to 3k minus 6k mu, E is equal to 9kg divided by 3k plus g. This is useful in ISRO exams. Now the volumetric strain in cylindrical rod. If there is sigma x, sigma y, sigma z, you can write this, no problem. Now you know Ey and Ex both represent change in diameter, and so this must be same. So after solving you get Ey is equal to Ez. It came automatically, I did not did any assumptions. It came by itself only. Now as we know, so this and this are both same, so this delta L by L plus 2 delta d by d. So delta L for L you can write this, so for cylindrical rod you will get this volumetric strain. Volumetric strain in a sphere, change by volume is equal to Ax plus Ey plus Ez is a basic formula. Ax is equal to delta d by d, because in sphere there is diameter everywhere. This Ey is equal to this, Ez equals to this. Now all three represents diameter, so this comes automatically. Delta y by d is equal to 3Ex 3 delta d by d, 3 times diametrical strain. Delta d by d is called diametrical strain. Now there is one more thing, that is circumferential strain. Now what is circumferential strain? Circumferential strain is equal to change in circumference divided by original circumference. So what is change in circumference? D pi d divided by pi d, original circumference, change in circumference, pi cut delta d by d. So if the question asks find the circumferential strain, so the circumferential strain is equal to diametrical strain is equal to radial strain. So I don't need to derive this again. but elongation in x direction due to load P is equal to PL upon AE, and if it is a non-prismatic circular bar, then it is 4PL upon pi E d1 d2, and if it is a rectangular non-prismatic bar, then the thing is there is no pi term here. PL upon no pi E into B. B is the breadth of this breadth. D2 minus D1 ln D2 by D1. D2 is equal to this and D1 is equal to this, means height. Here D1 represents height. If now the case 2 is parallel, if the thing is parallel, if two things are parallel, then the load is distributed and the elongation is same. Elongation will be same, but load carrying capacity, but load will be distributed. P is equal to P1 plus P2, but elongation will be same. Means consider it as individual things. This one and other one this. So due to load P1 and due to load P2, this is the elongation in this. No worries. This is valid for hollow, non-hollow, solid, everywhere. Just the term area changes. For hollow, the area is this, the hollow area. This topic is never asked and may be important for the GT 2024. Concept of equivalent Young modulus. What is the concept of equivalent Young modulus? Suppose this is the thing. एक रेक्टेंगल है, सेम ही रेक्टेंगल है, जिसके अंदर एक भाग जो है उसका मॉडुलस ऑफ वेलोसिटी E1 है, दूसरे भाग का मॉडुलस ऑफ वेलोसिटी E2 है. तो समझ लो जो जिसका E1 है उसकी एरिया है A1 और इसकी एरिया है A2. ये दोनों एक ही भाग थे, पर ड्यू टू समथिंग मे बी लाइक देयर इज़ अ वुड और दिस इज़ आयरन ब्लॉक, और दोनों साथ में है पैरेलली, मतलब जॉइंटेड है एक दूसरे से, और उस पर लोड अगर P लगेगा तो P दोनों में बटेगा. P इज इक्वल टू P1 प्लस P2, एंड एज दिस आर पैरेलल तो इनका एलोंगेशन सेम होगा. P1 P2 पर दोनों का एलोंगेशन सेम होगा. एलोंगेशन ऑफ component 1 is equal to P1 L upon A1 E1. Elongation of component 2 is equal to P2 L upon A2 E2. But both will be same because this is a parallel type of loading. It is wood and iron जो साथ में parallelly fit कर दिया गया. जैसे कि in suppose in where this case is useful in iron and concrete. आयरन एंड कंक्रीट एक दूसरे के साथ पैरेलल में होते हैं और थोड़ा लोड कंक्रीट लेता है, थोड़ा लोड आयरन लेता है. देयर इज़ अ क्वेश्चन, पीके हैज़ डन दिस क्वेश्चन दिस. सो अब इसको इक्विवेलेंट सिस्टम में बनाना हो तो इक्विवेलेंट पी लोड लगना चाहिए, एरिया होनी चाहिए A1 प्लस A2, और मॉडुलस इलास्टिसिटी होनी चाहिए E इक्विवेलेंट, और इलोंगेशन सेम आना चाहिए. इलोंगेशन कितना आएगा इसके से P इंटू एल, क्योंकि सबकी लेंथ एल ही है, अपॉन एरिया A1 प्लस A2 इंटू E इक्विवेलेंट. अब ये जो इलोंगेशन है और ये इलोंगेशन या फिर ये इलोंगेशन, क्योंकि दोनों इलोंगेशन सेम ही है, तो PL अपॉन A1 प्लस A2 E इक्विवेलेंट इज इक्वल टू P1 L अपॉन A1 E1 is equal to P2 L upon A2 E2. From this you will get E equivalent. This is the concept of equivalent Young modulus used in concrete and steel.